Morning, Algebra 1. Today we're going to do 3.6, APEX Semester 2. So we're just going to go over some equations that you guys have done and talk about rate of change and what rate of change is, how it relates. So for 3.6, we're going to start by talking about the standard form of an equation. So the standard form of a line is AX plus BY equals C. So slope-intercept form is y equals mx plus b. And then you have point slope form. That's y minus y1 equals m times x minus x1. As you're going to be using these formulas for the rest of your math lives, so don't forget them. Okay. So a couple of things here. So a, b, and c are all real numbers. Okay. In standard form, a, b, and c are real numbers. Okay? And an example would be 3x minus 2y equals 7. Okay? For slope-intercept form, m is the slope, also called the rate of change. So rate of change, right? It's the change of the y value over the change in the x value. And b is the y coordinate of the y-intercept. In other words, that's where it crosses the y-axis. So for this example, all they did was take this one and they got y by itself. So subtract 3x from both sides and you get negative 2y equals negative 3x plus 7. Okay? And then divide by both sides. Okay? So divide by negative 2 on both sides, and that gives you this right here. Okay? So that is your slope-intercept form. Easiest way to graph is in slope-intercept form. But then we also have point slope form, which you can actually graph from also, and I guess it's just as easy. So m here is also the slope, and x1, y1 is any point on the graph. Okay, so it's any point on that line. So here, the point 1, 3, 3, 1. Okay, so my 3 is with my x, and my y is my 1. That would be on the graph, and my slope would be 3 over 2. And notice this is the same exact equation or same exact line as both of these. It's just now in a different format. So you need to remember that slope is the same thing as a rate of change. So the formula for slope is m equals y2 minus y1 over x2 minus x1. So you're going to take any 2 points, you're going to subtract your y's and divide them by your x's subtracted. And the important thing is to remember that whatever y you use, whatever point you use for this y, you have to use the same point for this x. Okay. Another way that you'll see this written is with a triangle. That triangle is delta, and that's the change in. So that means the change in the y value over the change in the x value. Okay. So you want to start, thinking of this slope as rate of change. So it's the change in the y's over the change in the x's. Okay, so let's go ahead now and talk about the rate of change for a quadratic function. So rate of change for a quadratic function is very similar. Okay, so the first thing that we're going to do, it says use the table of values to help you find the average rate of change for each interval. So we're going to go from 0 to 1, we need a rate of change. So that's going to be our y's, so 2 minus 0 over our x's, which is 1 minus 0. And that's going to give us 2 over 1, which is 2. And we're going to do the same thing from 1 to 2. So that's going to be 8 minus 2 over 2 minus 1, because remember, these are coordinates. Okay. So that's going to be 6 over, 6 over 1, which is 6. Okay. From 2 to 3, it's going to be 18 minus 8 over 3 minus 2. So that's going to be 10 over 1, which is 10. From 3 to 4, it's going to be 32 minus 18 over 4 minus 3. So 32 minus 18 is 14. And then from 4 to 5 is going to be 50 minus 32 over 5 minus 4. So 50 minus 32 is 18. Okay. All right, so now let's look at what the rate of change. So it says, notice that the rate of change of a quadratic function varies between intervals. Okay, so this rate of change is 2, whereas this one is 6. Now, when we're talking about a linear equation, these are all going to be the same exact value. But it says, what is the difference between each rate of change? So in other words, what's the difference between these two? The difference between these two is 4. The difference between these two is 4. 4 and 4. This is called the second difference. Okay? So your second difference is the same in a quadratic function. So using a table, we can find our average rate of change, and then we can find our second difference, or our difference between the average rate of change. Let's use a graph now to find the average rate of change between points. So we're going to go from x equals 1 to x equals 3, which is this one right here. So I'm going to use these 2 points. So this coordinate is 3, 10, and this coordinate is 1, 2. Okay, so I'm going to say 10 minus 2 over 3 minus 1 is going to be 8 over 2, which is just 4. All right, so now let's go on ahead and let's find the rate of change from x equals -2 to x equals -1. So from here to here, so this coordinate is -1, 2, and this coordinate is -2, 5. I'm going to say 5 minus 2, so my y's, divided by -2 minus -1. So now I'm going to get 3 over -1, which is -3. Okay, so notice the rate of change, or the slope of this line between these 2 points, is different from the slope of this line between these 2 points. Okay? But if I were to find from here to here, it would match up. Oh, not with that one. It would match up with this -3, except it would be positive, right? Because these are mirror images. Okay, so it's going to change depending on where you're looking. Let's go ahead and take a look at exponential functions. So the equation of an exponential function is a times b to the x. Okay, so this right here, if b is greater than 1 and a is greater than 0, then we know that our graph is a graph that increases. 0 is less than b is less than 1, but a is greater than 0 is a graph that decreases. And 0a, so whatever that a value is your y-intercept. Okay, so let's take a look at average rate of change and the patterns for an exponential function. Okay, so for an exponential function, we're just going to go from 0 to 1, so that would be the y's would be 3 minus 1 over 1 minus 0. Okay, so that's going to be 2 over 1, which is 2. From interval from 1 to 2, so x is 1 to 2, it's going to be 9 minus 3 over 2 minus 1, which is 6 over 1. 2 to 3 is going to be 27 minus 9 over 3 minus 2. So that's going to be 18 over 1. And then we're getting into some big numbers, so we can go on ahead and keep doing this, but let's take a look at what the pattern is. So here from 2 to 6, okay, what is happening to get from 2 to 6, and then what is happening to get from 6 to 18. Okay, so now remember, with an exponential function, we're talking about a ratio, we're talking about multiplication. So we're going to multiply times something. So from 2 to 6, we got to multiply times 3. From 6 to 18, we also multiply times 3. So this right here is called our ratio. Okay. So 18 times 3, once again, we could continue to do our slope formula, or we could multiply this by 3 and we get that 54. Okay. And then 54 times 3 gives us 162. And then just to show you, so if I did, I'm going to do 4 to 5 just by hand to show you. 243 minus 81 over 5 minus 4. Well, 243 minus 81 is 162 over 1, which is 162. All right, so we are going to, and once again, that's called a ratio, okay, of change. So now we're going to find the ratio, or the ratio of change, the rate of change for the interval from x equals 1 to x equals 3 here. Okay, so x equals 1 to x equals 3. Okay, so remember that when we are finding a rate of change, we are just finding the slope. So if I want to find the slope of this, I'm going to take the 2. Right, so we're finding the slope of the line from here to here. So I'm just going to sketch a line in. I was trying to find a ruler, but I couldn't find one. So we're actually finding the slope of that line right there. Okay, we're not finding what this curve is. We're finding the slope right there. Okay, so from 3 to 1, it's going to be 27, because that's my y, minus 3 over 3 minus 1. So 27 minus 3 is 24 over 2. So it's 12. So my rate of change is 12. So in other words, my slope from here to here would be 12 if I go up and over. Let's go on ahead now and let's find our rate of change from 3 to 4. So same thing here. And look, someone brought me a ruler. All right, so from 3 to 4, I'm actually finding the slope of this line right here. Okay, so it's going to be 81 minus 27 over 4 minus 3. So 81 minus 27 gives me 54 over 1. So my slope, or my rate of change, is 54. Okay, so when we're talking about a rate of change, even though we're dealing with these curved graphs, we're still actually talking about just the slope of a line between those 2 points. Okay. All right, so that was all for chapter 3. Have a great day, and I'll see you all next time.